What up, Dons? Today, Parker, Tommy, and I will be showing you the physics of skipping a rock. Let's get it.
Oh, dude, Tom, a pond, dude. We should totally skip rocks off that thing.
Nice tree. Wow, Tom, look at the beauty of that tree. Wow. Oh my God.
Rocks with you guys? Phil, that's not how you skip a rock. You need to skip it on water.
Yeah. Now it's time for the main event, baby. Actually skipping a rock. Let's go. Explanation time.
Before we talk about the physics, we have to talk about spin first. Spin stabilizes an object and keeps it from falling into the water. A minimum speed must be achieved or the stone will hit the water and immediately sink. Flat, round stones are the best because the surface area creates a balance on the impact, like this one. The fat, like heavy rocks don't skip across the water as well. But the magic angle between the spinning stone and the water should be about 20 degrees in order to achieve maximum number of skips.
A stone's interaction with the surface of water, however, is different. Each time the stone skips the surface of the water, it is reflected upwards. Its downward velocity is reversed, and its horizontal velocity is reduced. Since the trailing edge of the stone typically breaches the water first, it is also pitched down slightly. The brief downward pitching affects the direction of the stone's path. Each subsequent bounce slows it down until it penetrates the water surface rather than skipping over it. The height from which it is thrown, the angle, the impact at altitude, and the condition of the water surface all are additional factors that affect how many skips occur and how quickly the stone splashes down.
The principle of the conservation of momentum determines that the stone enters the water and pushes some of the water downwards. The stone is forced upwards. This force is equal to the hydrodynamic pressure on the stone multiplied by its area. Assuming that this force is balanced against the weight of the stone, then mg, where m is mass and g is the acceleration due to gravity, there's a minimum velocity and a velocity greater than the minimum will bounce. In other words, a stone has to have a minimum velocity in order to skip. If the velocity is less than this value, the stone will hit the water and sink.
Yes,